Our next problem is our morning compass correction. So we're at 0700, we took an azimuth of the sun, and we're going to use that to correct our gyro compass and determine our deviation. I know in the last video I just said we're not going to base a new track line off the previous one, but considering that this is so dependent on our DR position, I don't know what we should do about this, but I'm going to say that we're now using this as our new 0540 time. And we're just going to base everything off of that. So we're going to find a DR position with that being 0540 for our new shot that's going to occur at 728. So 728 to 540, let's see, that's 20 minutes from 540 to 6, an hour from 6 to 7, and then 20 minutes from 7 to 728. So it's 108 total minutes times 15 divided by 60, 27 miles. So we would have gone 27 miles, which is going to get us right back 27 miles. You'll see in a second. I don't know what's wrong with the person that made this. Gets us basically at the same point that we were before. So we're going to erase that DR position. Luckily, our fix landed right on the track line, so we don't have to draw a new track line. But if it landed over here, we'd have to draw it over there. But we're going to treat that now as our 0727 shot. We're going to find that DR position, and then we're going to use it for our calculations of what the azimuth of the sun should have been at that time. Okay. Sorry. Here we go. So we're going to do azimuth. Our DR position we're going to find now. Let's see. It's probably, latitude is probably like 1 minute above. Yes, it is. Okay. So latitude is 18 degrees. 1 minute north. Longitude, if you measure, comes to there, which I'm not going to bother moving the camera, but it is 16 minutes. So 162 degrees, 16 minutes. Okay. Now that we've got that, we could set up the problem for our azimuth. So remember, for an azimuth, we're going to look for zone time, zone description, GMT. And then from there, we're going to find the GHA hours. Remember, working with the sun here, minutes and seconds, GHA. And then we're going to use our DR longitude, not our assumed longitude, to get our LHA. Off to the side, we're going to get declination, D, dec, and then assumed latitude. Okay. So our zone time was 0 or 7, 28, 15. Our zone description is still minus 11. So that's going to give us, let's see, 7 plus 24 is 31, minus 11 is going to get 20. So 2000, 28, 15. And from there we can go into our almanac. I should have bookmarked the page because we're going to be using November 4th for the whole day's work here. Here we go. Or November 3rd, technically, and then into the 4th. So at 2000, we've got a GHA, sorry, we should be using the sun. At 2000, we've got a GHA of 124 degrees, sorry. Why is that still blurry? All right, 124 degrees, 6 minutes. 124 degrees, 06.0 minutes. And then we had a declination of south 15 degrees, 13.6 minutes. South 15 degrees, 13.6 minutes. And a little d value of 0.8. We are in November. We're obviously in the winter time, before the solstice. So this is going to be a positive 0.8 because the numbers go up. Good. And now we can go to minutes and seconds. We're looking for 28 minutes and 15 seconds. Here we go. 28 minutes. We're following the sun and planets. 15 seconds gives us 7 degrees, 3.8 minutes. 7 degrees, 3.8 minutes. And little d of 0.8 is equivalent to 0.4. Okay. So now we can write south 15 degrees, 14.0 minutes. And let's see, 09.8, 131 degrees. Good. We're going to throw in our dr longitude. By the way, this should be dr latitude. Dr longitude of 162 degrees, 16.0 minutes east. Our dr latitude of 18 degrees, 1 minute north. And our LHA, we're in the east, so east is add as always. And we'll do 0.8, 25. Then 131 plus 162, which is 293. All right, we got our LHA, our latitude, and our declination, and we can now come to the book. But remember, this is an azimuth problem, so we're going to have to perform triple interpolation. So we're going to set up our table here, declination, latitude, LHA, and we're going to be getting tabulated z plus 1, difference, and correction. Okay. Now that we've got all that ready, we can find our initial start. So our latitude is again 18, so we're in the first half of the book. Our LHA is 293, which if we go this way, 297, 96, 89, 92, 93, 293. Our declination is in the south, and our latitude's in the north, so we're going to come to contrary side. And we're got our latitude column of 18 degrees. Declination is 18 as well. So we're going to follow this down, and we're going to get right there. Yeah, 115 degrees. So tabulated z or base z is 115.0. Z plus 1, we're going to go to declination first. So if this is 115, next is 116. That's nice and easy. So declination is 116. For latitude, we're going to skip over to the next column. So if we've got 18 here, 19 gets us 115.3. 115.3. And then LHA, we have to turn to the next page, which the next page is actually previous page for us to go up to 294. And then 18 and 18 gets us 115.4. 115.4. Now we have to find the differences between these three. Declination is 115 and 116, so that's obviously plus 0.1. Latitude is plus 0.3. LHA is plus 0.4. That's what I forgot. The minutes. The minutes of our values, and then that'll give us our correction from there. So now we need to carry over the minutes of our values. The minutes of declination is 14 over 60. The minutes of our latitude is 1 over 60. So this 1 in 0.3 is going to come out to 0. And our LHA is 25.8 over 60. Now we can do our interpolation. And we've got 14 divided by 60 times 1, obviously. We're going to add that to 115. We're going to get 0.23 repeating. Then we'll do 1 over 60 times 0.3 gets us 0.005, so essentially nothing. 25.8 divided by 60 times 0.4 is 0.172. These all happen to be positive, so we're just going to add them all together, and we get plus 0.05 plus the 0.23 repeating. We get 0.41 degrees. We're going to apply that positively to our base z. So 115.0 plus 0.41 will be 115.4 degrees. And that is our z. Now finally we have to do our zn problem, or correction. So we're in the north. Our LHA was 293, so LHA is greater than 180. Zn equals z. So our Zn is 115.4 degrees. So now we've got the true bearing of the sun at the time of our shot. And we're going to use that to perform our compass corrections. We see in our problem, our bearing, our morning compass correction had a bearing by gyro of 112 degrees. So we're going to set up our get and our can dead man vote twice at elections. We know our gyro bearing of the sun was 112 and our true bearing was 115.4. Then we know that our gyro heading was 285, so we're going to use that once we get our error to get our true heading. And our compass heading was 296, and our variation was 8 west. Okay, now we just need to connect the dots. So 112 to 115.4 is 3.4 degrees. It's increasing going this way, because remember, it's plus east this way. So we're going to get 3.4 degrees east as our gyro error. So then if we apply that to our gyro heading of 285, we get 288.4 degrees as our true heading. We'll carry that down here, 288.4. Now we're going this way to get to a deviation. So west, going this way, you add. So 288.4 plus 8 degrees west gets us 296.4. Then we've got 296.4 versus 296. So the difference is obviously 0.4, and it's increasing going this way. So our deviation is 0.4 degrees east. And this satisfies me because it more or less proves that I was right in guessing that we should set our DR position here, because that could have very easily thrown everything off. But there's our azimuth problem for this project.